Hello, Professor. Today I want to introduce the Lecture 8 summary. I'm today's presenter, Jiajun Jiang. And here's the agenda. First, we're going to start with the memory hierarchy, and then a floppy disk memory. And I will show you how the encoding technique, and then it's hard disk, and the disk array, and the final is RAID. The memory hierarchy is, we can see from this picture, and there's a lot of level. The level 1 is the most close to the CPU, so we can see the y-axis. When it goes down, it will increase the distance from the CPU and increase the access time. But also, when the level number goes up, we can see the size of memory are increased. So if we want memory have a very quick access time, but the size of memory will be pretty small. On the other hand, the size of the memory is very big, the access time will be longer. And then is floppy disk memory. We can see the picture. The track is a concentric circle of the data stored on the surface of the disk. And sector is a subdivision of the track. The clusters is a group of sector, and finally cylinder. The cylinder is a set of a track. The memory is already right on the floppy disk memory, the surface. So how do we write the memory or read the memory from the disk? There are two methods for encoding technique. The first one is FN, which is frequency modulation. In the daily life, we might see the floppy disk is very smooth and shiny, but actually there's a lot of little gap on the surface to store it is 0 or 1. And how do we read those data is there's two transitions. The first one is clock transitions. It will always switch the poles. When it switch, you can know there's another data is coming. Second is data transition, and this is the transition to contain the data. We can see the picture. There's a blue line and red line. The blue line is the clock, the red line is the data. The clock will switch all the time, we can see, and if the data is 1, then the data transitions will switch. If the data is 0, it will do nothing. So this is the first technique for the head to read the data. Is the second technique is called modified frequency modulations, which is advanced from the frequency modulations. The main difference between those two is the NFN reduce the number of the transitions and increase the density. So we can see from the picture, the NFN clock transitions won't switch all the time. It only switch when there's a 2 consecutive of 0. And then is disk formatting. We cannot use the whole space in the disk because there still needs some space to store some necessary information. Like we need to store the disk controller to access the information in the disk. So we cannot use the 100% of the disk. And this is 3 main organization in the disk formatting. The first one is boot record. It will store the disk type, the sector density, number of sectors, and other information. And then is the directory. It provides a list for all the file location in the disk. And then is file allocation table to store where the file is located. And then is hard disk memory. The hard disk memory is made of solid metal platters and use a file head to store and read the data from the disk surface, so it doesn't need to touch the surface of the disk. The hard disk store data in sector is used 512 byte long. The data is addressed in cluster of 9 or more sector on most hard disk drives. The hard disk drive can use the modified frequency modulation or the round length limit to store the data. And then is disk access time. The access time will equal to seek time and settling time and latency time. The seek time is the amount of time that the read or write head have to take to find the cylinder or the track. Settling time is the time it takes the head to stop, and is a rotational latency. The rotational latency is the time it takes for the head to locate on the specific sector. The time depends on the RPM. And then is the hard disk interleaving. We can see the picture. We know the data is stored on the circle, but when the RPM is the same, the circumference will be longer when the radius will be longer. So the RPM is the same. We cannot read the data on the same frequency. So we can see the picture. The smallest circumference will be 1, 2, 3, 4, 5. But when we see the outside of the circumference, the number will be 1, 7, 13, 2. Because the RPM is the same, we have to skip some sector to read the accuracy data. So we can see when the circumference is 3 to 1, we have to skip the 3 sector to find the accuracy data. And then is disk array. The disk array is equal to storage array, and we can say storage content array of HDD. And the arrays is combined drives into one scalable system. The main reason we use the disk array is to the data distribution. We can acquire some benefit from data distribution. The first one is independent addressing, and fine-grain stripping, and coarse-grain stripping. But the problem is if we access the same area, like if we access the A1 for 100 of times, or there's a lot of 100 people want to access the A1 in the same time, we have to wait a lot of time. So we have to concern the workload to determine the strip size, because to avoid all the user access the same area at the same time. And the final is the RAID. The RAID disk array is a disk area composed of multiple hard disks. And the main reason we will use the RAID is it has the fault tolerant mechanism. So when the hard disk is fails, the data can still be retained when using the RAID. And the right picture is to show us there's a lot of different levels for the RAID. The level 1 is just the disk array without fault tolerance. It means if you lost the memory, it will be gone. You cannot fix it. And the level 1 is the mirroring. You just there's 2 disks, and the disk 0 and the disk 1. The disk 1 is the mirroring of the data for the disk 0. The level 2 RAID is the advance from the RAID 0. It will encode the data and split it into independent bits and write the data back to the hard disk. And it will also add some error correction code into the data, so the data will be larger than the original. The level 3 is called bit interleaving, and it means it will separate the data into different disks. So if we want to read a memory, you may have to read from all 4 disks to obtain the data we want. And the level 4 is block level stripping with dedicated parity. In write must update disk with the data and the parity disk. The level 5 is block level stripping with distribute parity. The parity is separate out across disk in a group. Different update of parity go to different disk. And the level 6 is block interleaving with double parity. And that's all I have for today. Thank you, Professor.